Here we see our two-dimensional grid once more. You have noticed in the last implementations, the only attributes that we care about a tile are the color and their positions X and Y. It turns out that there is no need to create a compound data type of class tile in order to generate the effects and implement the algorithms that we have seen so far. As each tile in the grid becomes smaller, they approach the size of a pixel. So we can assume that in an extreme case where the resolution is equal to 1, the width and the height of each of the tiles is the size of 1 pixel. The points that we care about this time are simply each of the dots or pixels, which are the fundamental unit of visualization in a screen, and their coordinates X and Y are going to be fed into a helper function that will map those traits into an output value. Today we will see a particular type of function. It's called an implicit function. The regular way to think about mathematical functions is as a relationship between two variables. The dependent variable y is equal to a particular relationship of a variable x. Depending on the transformations that we make in that variable x, we have a corresponding value y for each of these points in x. Let's take a look at y equals x plus c. Let's call c 10, it's just a constant. You can see here that the effect of that constant makes the line get skewed towards the left. What happens if the value 5 is defined by the relationship of the variables x and y? This time, the parameter x is not associated to the variable y. That is to say that x doesn't help explaining y. These are two independent variables. It's a form of multivariate function that in this case provides as a result the number 5, which is a constant. What we are looking in Desmos right here is not a mapped point between x and y, but rather that region in space where the addition of values in x and y is equal to the constant 5. To demonstrate, look at this point here. This is the coordinate 0, 5. If x is 0 and y is 5, then the result is equal to 5. The same happens when the x-axis is 5 and the y-axis is 0. Any point in between will provide something similar. The point 3, 2 is equal to 5 as well. This straight line may not be as interesting to demonstrate the usefulness of an implicit function. However, there is a very special form of mathematical relationship that happens when you raise these components to the square. When you do so, you end up with a circle. If we add exponentials to the relationship in x and y, we're going to end up with more interesting shapes. This one right here is known as a hyperellipse. Let's make this a rectangle. There it is. This shape right here has a lot of history. For those of you that are fans of football soccer, this is the same shape that inspired the shape of the Azteca Stadium in Mexico City. It is a hyperellipse. So let's start with this equation, and let's see if we can implement it using Python.